Right, here we go. Figure above shows the graph of f prime. So I would make sure I don't forget that that's f prime. The derivative of a twice differentiable function f. That's sometimes important. On the closed interval 0 to 8. Okay, there's a period, so I stop, make sense of what I've got. So this is f prime, 0 to 8, good. Graph of f prime has horizontal tangents at x equal 1. I can see that. X equal 3. I can see that. And x equal 5. So I'm good there. Period. Anyone have questions to that junction of the problem? Oh, they don't say, so don't count on it. No, good question. Two troubles. Yeah, don't, if they don't say, don't assume. Okay. The areas of the regions between the graphs of f prime and the x-axis are labeled in the figure, period. So the areas are going to be important. Questions? The function f is defined for all real numbers and satisfies f of 8 equals 4. So that's important. Question? If you're writing, you're making sense. If you're just reading, you're stuck. So do something else. So far, I'm good. Find all values of x. So I'm going to circle that. Find all values of x from 0 to 8, for which f, that's important, has a local max. No, sorry, local min. Ah, I about made the same mistake. Huh? Coffee and water. Find all values of x on the interval for which the function has a local min. Justify your answer. So I remember from my flashcards that f will have a local min when f prime changes negative to positive. So I just need to find that right here. So I write at x equals, I better count that so I don't mess up, 2, 3, 4, 5, 6. Come on. 5, 6. So at x equals 6, f prime changes negative to positive.
You do an egg and then an arrow
I think I'll give it to you. I would prefer to say that. F prime changes negative to positive, so f has local max. I keep saying that. Local min at x equals 6. That's 1 point. Please. I think they'll give you that one. Yeah, I think they'll forgive you for that. It is actually in terms of x, but I think they'd let that go. Anybody else? Please. Okay.
I just said it happens at x equals.
Read exactly what you wrote. Just read it.
At x equals 6 because that's where it is.
I think they'll give you that because they were only asking for a local min. So I think you're okay. Would have been better to say a teeny bit more, but I think you're okay. It doesn't hurt anything to know for sure. I don't seem to struggle with that, so I didn't think of it, but that's not a bad idea. Read it one more time. Yeah.
At x equals 6 because that is where it is.
Oh, you're right. You won't get the point. Because it doesn't tell the Great Mexico. It doesn't refer, we don't know what it is, so you won't get the point. It's why I tease you from the very start of the year that you can't use the word yet. Good question. 2 more pebbles for kids. Anybody else? Okay, nice catch. That's very good. I didn't know that. Next one. Part B. All right, it says determine the absolute minimum, absolute is the key word, of f on the closed interval 0 to 8. So I remember the min-max theorem. F will be least at the beginning of F, the end of F, or any critical points of F. Oh,
Doesn't have any critical point,
no, 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 no. Sorry. Yeah, hey, listen. The min-max, that's a good question. The min-max theorem says, don't talk. F will be least. Let's make this click. Let's keep talking until this clicks. Look, 24 days to go. You gotta keep clicking. It's gotta make sense to you. Okay, F is least at the beginning of F, the end of F, or where F has a critical point in between. What you're remembering is F has a critical point where F prime is 0. Okay? But it's where F has a critical point. But let me say one more thing, 1 second. You can kind of get, that's the general min-max theorem. If you want to make it a little more specific, you could say this. F will be least at the beginning of F, the end of F, or where F has a relative min. You can think of it that way. That's a little more specific, and that's perfectly helpful in this case. Blake has a question, then Aaron.
Okay, so the min-max theorem only works for those absolute minimums, not for the locals. And me and you were kind of talking about this earlier, but so like the critical point on this graph, because it's not changing from the negative to positive, that's why it's not a minimum. But it's
Yeah, so what you're doing, hey, look, make sense of this, it really helps. What you're doing, Blake, you're understanding it very well. You're kind of using a more specific, okay, so talk. The first thing I'm saying is the general version of the min-max theorem says F will be greatest or least, the beginning of F, the end of F, or where F has a critical point in between. We can make it more specific by saying F will be lowest at the beginning of F, the end of F, or where F has a local min. So you're right. Here's F prime. Here is F prime equaling 0. But I don't have to worry about it because that's not a local min on F. That's just a critical point on F. Here F prime is also equal to 0. I don't have to worry about that one either because that would be a local max on F. So really, all I have to worry about is the beginning, the end, and the spot where F had a local min.
If they weren't shown a graph,
You have to remind yourself, every AP question is a puzzle, and they'll give you the information you need to figure it out. So here's some examples. I've seen a lot of AP questions where they want you to find where F has a absolute minimum, and instead of a graph, they'll give you an equation and your calculator. So you can graph what they're giving you. What else have they done? I've seen some where they just give you an equation, and they don't give you your calculator, and you'll have to do a sign chart. But with the sign chart, you can get the same information again.
if it's 2 points, what for this also just
That won't happen. You'll have a graph of F prime, and if you don't have a calculator, you'll make a sign chart of F prime, and from the sign chart of F prime, you'll be able to immediately see where F has local minimums and local maximums. There won't be the issue you're talking about.
All right.
Go ahead. Go ahead. Yeah, sorry.
So, and what was it when we had the 2 different points?
Oh, I got you.
Which one's higher?
I misunderstood what you meant. So, in this case, we know that F's going to be lowest either at time 0,
Right.
time 8, or time 6. And they're not really times, but it's okay to think of it that way for a second. So yes, we do have to test all 3 now to figure out which one is lowest.
Some because we can see that that's really not going to be a low one. That's going to be a high
You
one.
could, but you do have to justify. I think it's easiest to justify just by doing the integral. It's quicker than me trying to explain the integral.
Right.
So I'm going to just do the integral.
And then I'm just also wondering on potential points of F. I understand that that would be where F prime is 0 or in time. What about where F prime is like just not having any points necessarily? You don't know.
That means F prime would be undefined. So that would be a critical point of that.
So that was
Is that what you meant?
yeah.
Perfect. Okay.
I'm just curious about how we would write that, because you want in your explanation to point out the fact that it could either be at x equals 0, x equals 8, or x equals 6.
Right, I get you. No, I'm with you 100%.
Right out there.
Here's what I would write. Okay, no one talk, just watch closer. You're spot on. It's exactly the dilemma. Now you're understanding the situation. How much do you have to write? You don't have to state the theorem. That should be kind of guiding your work, but you don't have to state it. So what I would write is F, because I'm going to write the theorem big because it just seems to make easier sense to me to make sense of what I'm writing. So I'm going to say F is least at x equals 0, x equals 8, or where F has local min. You can have poor grammar, they don't care. Which is at that's what I'm going to write.
So you don't have to write because of this.
You do not.
That's
Just state it's good enough. Yep. Basically, your two options are, well, there's more than two. This is the best. We'll just go with the best option if this makes sense. Everybody good here? Okay. So now you have to prove which of those three is the least. I think the easiest way to prove is with integrals. So because I have a graph of f prime, I can say f of 0, I already know that one. F of 0 is, oh, no, I know the other end, don't know f of 0. So let's do this then. The fundamental theorem would guarantee the following. If I integrate from 0 to 8, f prime, that will be equivalent to the change in f between 0 and 8. Is everyone okay with that? Okay, rearranging, you're going to get f of 0 is equal to, so I add this over, move the integral, so it's going to be f of 8 subtract the integral. Questions to there, please. They're giving me f prime. If I want to find f, that's how I always find out. There just isn't any other way. There's no other way to do it. Please, Devil.
I wrote f prime of p instead of f.
I think they'll forgive that one. I do. Anybody else? Okay, cool. So I go to work. So f of 0 equals, f of 8 is given as 4. When there's a minus, you better put a parenthesis. Okay, I have to integrate f prime from 0 to 8. It's really easy because they've given me all the area. Area above the axis counts positively, area below counts negatively. So it's 2 plus 6 minus 3 plus 7. And I'd stop right there. Well, I can't stop though because I have to make a comparison. So I've got to keep going. So that's 8 minus 3 is 5. 5 plus 7 is 12. 4 minus 12 is negative 8. Question? Please.
Okay, so it's negative 3 because it's below the x-axis.
Pebbles.
You're just integrating that area that where it is something like that, is that still count negatively?
What I think you're confusing it with is if you had some other problem and they said, hey, go find this area, you would create an integral that would come out with an answer of positive 3 because you'd be finding that area. When we're using a known area to compute the value of an integral, you must count below as negative. Question? Pebbles, anybody else? So whenever you are integrating graphically, area below the axis counts negatively. Is that what you mean? So we need to find f of 6 now. So f of 6, using the exact same logic, would be f of 8. Subtract the integral from 6 to 8. So that's going to equal 4, subtract, parentheses. If I'm integrating from 6 to 8, that integral is 7. So that would be negative 3. Therefore, f of x is least, determine the absolute minimum value, is least at x equals 0, where f of 0 is equal to negative 8. And that's how you get to 3. Please.
So, you said we want to try to find the area graph.
Let me say it back to you. If you are integrating graphically, meaning you're using a graph to find the value of an integral, you're integrating from left to right, area that is below the x-axis counts as a negative value.
So, let's say every area would hold the lines and it would be.
Yes, so what you're saying is something like this. If they had given you a picture that looked like, if f prime were something like this, maybe, I don't know. Oops, back up a little bit. Like that.
Yeah.
In this area we're 9, in this area we're 10. This is, say, 5. The integral from 0 to 5 of f prime is equal to negative 19. Is that what you meant?
Yeah.
That would be that. Yeah, like that. 2 per page. You know? Awesome. Next one. On what intervals contained in 0 to 8 is the graph of f both, here's the key word, both concave down and increasing? Okay, so I need Danica's chart. So f prime, f L prime. Okay, so looking for when f is both concave down and f is increasing. So now I just need to write the words. So I write, so f is increasing where f prime is positive. F is concave down where f prime is decreasing. This occurs for, let's look. So you need to have f prime be positive and also f prime decreasing. So that would be here and here. So we go 0 to 1 and 3 to 4. Wait a minute. 2, 3, yeah, making sure. 3 to 4. These are intervals. Hey, so these mean the same thing. Yeah, this means from x equals 0 to x equals 1, open interval. From x equals 3 to x equals 4, this is fine. Open means not included. So you start right after 0, stop right before 0. So go ahead.
So, do we have to say it separately, or can we just say, I said.
Okay, everyone, no one talk because I want to hear it. Shh, don't talk. Just read it exactly.
Because I said 0 to 1 and then 3 to 4 because f is concave down and increasing when f prime is positive.
That should be fine. You have the exact same intervals, right?
Yeah.
Yeah, you should be fine. You just said it the other way around, so that's okay.
Do you
2
not
point.
like say it like separately?
No, just read it one more time. It was perfect.
F is concave down and increasing when F prime is positive.
I think you're okay, because you said them in respective order, right?
Yeah.
Yeah, you should be fine.
So I wrote, because F prime is positive and decreasing from the intervals, that makes F of X concave down and increasing from the second interval.
I think you're okay. Need you to list the interval. Yeah, you should be okay.
Instead of looking at it like that, you say, for, 0 is less than.
Yes. Perfectly
3 is less
equivalent.
than.
Yeah, writing, hey, this is exactly the same thing as this. They mean exactly the same thing. There's no difference. So either way, it's actually, yeah. Oh. Please, Jake.
So because it says it's a closed interval, I included 0 in that.
I think they'll forgive you, but here's the deal. Hey, here's the rule. Listen. When it comes to concavity, the strict mathematical definition never includes the endpoints are just tricky. In the middle of an interval, they never include the end of the interval. It's like they would never say concave down, including 1. That's just the strict mathematical definition. This endpoint over here is a bit iffy. So the safest thing to do is just always use open intervals. But I think they'll be forgiving because it's kind of a strict technicality they're not too concerned about. So, please.
Is there ever a time where they're going to strict on closed intervals?
I don't think so. So I just, most of the time I will use open interval. Once in a while I'll notice that closed seems to make sense, but it just depends on the question. But open interval I tend to use more often, it's a bit safer. So. With a hole you wouldn't use closed because you don't want to include it, you can use open for sure. Right? Anybody else? Awesome. Okay. Part D. The function g is defined by this formula, so I would definitely box that. Here's g. Okay. They give a value for f of 3. I don't really know why yet, so don't worry about it. Find the slope of the line tangent to the graph of g at x equals 3. Okay. Slope of the line tangent to g means the value of g prime at 3. So I'm looking for g prime at 3. Here we go. So g prime at 3. So I have to find g prime first. You need me to clarify why I'm doing it. Awesome. So that means I use the power rule. So bring down the 3, multiply by the something, raised to the 3 minus 1, which would be 2, multiply by the derivative of that something. We need a question. You want to have a question there? Please.
Do you have to have the parentheses around that otherwise if you use right 3 f of x? Or
I've never seen it written that way, so it makes me nervous. Like, I want to say yes because I like it better, honestly. But I have to go look up and see an example. So it made me nervous to write it that way. That makes sense. Couple. Good there. I just don't like that notation. I don't feel comfortable writing it.
okay.
You're okay.
So this is probably just the rule, but why is the f prime of x on that? Like why did we just stop at f3 f of x first?
Oh, the rule is the derivative of, you just forgot the rule. Every rule you have, the derivative of something to a number, they all incorporate what's called the chain rule, so they all end with derivative of the something.
So you just, when you don't put it, it's just because they cancel out?
Right, because what happens sometimes is you end up with dx dx.
Oh.
That's all.
okay.
Is that, you good?
Yeah.
2 pebbles. Anybody else? So now it's a matter of, I'm just hurrying a little bit. So now we plug it in. Don't forget, take advantage of the fact that I'm not giving you an FRQ to play the game, redo an FRQ, come talk, do something to get better. You gotta work day by day. Test next time. I'm gonna finish this. So that means G prime of 3 is equal to 3 f of 3 squared f prime of 3. That's 3 f of 3. They gave it to me negative 5 halves. Negative 5 over 2 squared. F prime of 3 is on this picture. F prime of 3 is 4. And I would stop right there and get your points. So that's 3 points.